AI tech is moving crazy fast. Modern LLMs now support massive context windows, up to 1 million tokens. So some people think that RAG is already obsolete. But the truth is, most advanced AI systems in the world still rely heavily on it. In this video, I'll explain what RAG actually is and show you real RAG use case for writing academic papers. People often get confused by RAG because it overlaps with other AI concepts. To understand it, we first have to understand the problem it solves. Out of the box, an AI model is isolated. It knows a lot, but its knowledge is frozen in time. If you wanted to know about your private company data, brand new project, or just recent news, you need a way to extend its knowledge. And there are three main approaches for this. The first one is context engineering. Every LLM has a limit to how much text you can send in a single prompt. And today those limits are really huge. You can drop entire books into a chat, and often that's all you need. But there are two concerns to keep in mind. Cost. The more text you include in the context window, the more tokens the model needs to process. And the second is scale. Even the largest context windows are still limited for many real-world datasets. Imagine 5 years of company documentation, thousands of wiki pages, or hundreds of technical books that you want your LLM to use as a knowledge base. You simply can't send all of that to the model in a single prompt, and even if you could, you would go broke paying for it. The second way to extend LLM capabilities is tool calling pattern. Instead of giving the model all the possible information up front, you give it selectively with the access to tools. So it could browse the web, read specific files, pull data from an API or database on demand. This turns simple chatbots into smart agents. By the way, I have a whole video on how this works with MCP, which you can check out right here. Finally, the third way is RAG, which stands for Retrieval-Augmented Generation. RAG is a Gen AI pattern that allows LLMs to access really large knowledge bases without retraining the model. Instead of overwhelming AI with entire library of docs, we store information on a site in a storage highly optimized for a similarity search. So when a user asks a question, the system quickly searches and retrieves only the most relevant pieces of data and sends them to the model. Let's walk through the process step by step. First, large documents are split into smaller pieces called chunks. This makes searching faster and far more accurate. Next, an AI model converts these chunks into vectors, basically sets of numbers that capture the meaning of the text. Think of a massive map. Sentences with similar meanings sit close together, while unrelated ones are far apart. Vectors are simply the coordinates on this map. All these coordinates are stored in a specialized vector database, built for lightning-fast searches. So what happens when you ask the AI a question? The system turns a question into its own vector. It then searches the database for the closest matching coordinates to find the most relevant chunks of text. Let's look at a very simple example. Imagine your knowledge base contains 3 text chunks. Cats are small domesticated animals, often kept as pets. Dogs are loyal animals, commonly trained by humans. And neural networks are used to train machine learning models. During indexing, the embedding models converts each chunk into a vector. The cat and dog vectors will sit right next to each other on our map, because they're both about pets. So if you ask what animals are commonly kept as pets, that question becomes a vector too. Now the vector database calculates similarity between the query vector and each vector it stores. The system then selects the top results. In our example, the retrieved chunks are cats and dogs text. The neural network's chunk is ignored because it's semantically far away. Finally, system combines your question with these matching chunks. This is called prompt augmentation. The AI then uses this highly focused information to generate your response. This approach has some huge benefits. It costs less, handles massive datasets, and drastically reduces hallucinations, because the AI only looks at the exact facts it needs, without getting overwhelmed. While standard approach with large context windows is great for solving quick questions, RAG is still essential for searching massive collections of data, like company archives or research papers. So even as AI models get better at reading long text, RAG still remains incredibly relevant. Now let's bring this into a real world. Imagine you need to write an academic paper. You need credible sources, proper citations, and solid arguments. This is the perfect use case for RAG workflow. But instead of coding this system from scratch, we're gonna combine three powerful tools. First, we gather the research papers. Great tool for this is Elicit. Elicit is an AI search engine designed specifically for finding peer-reviewed academic papers. You ask a research question and it retrieves relevant papers, extracts insights, and provides access to the PDFs. At this stage, we're effectively building the retrieval layer of our pipeline. Next, we upload the sources into Notebook-LM, which acts like a ready-to-use RAG system. When you upload documents, it automatically chunks the text, creates embeddings, indexes the information. Notebook-LM allows to upload up to 50 sources to one notebook. This creates a closed knowledge sandbox where the AI only knows about the sources you provided. You can then ask questions like, what's the main findings across these papers, which papers disagree or contradict with each other, and the system answers with citations directly linked to the sources. Finally, we take the structured insights and breathe them into Gemini 3.1 Pro. Models like Gemini Pro are excellent at reasoning and writing structured content. An assistant like Gemini Gem can directly integrate with Notebook-LM as a knowledge base. Now we can ask it to draft the introduction, structure literature review, and write academic-style prose. Because the information already comes from real research papers, the model generates text that is grounded in factual sources. That's all I've got for today. If you learned something new, hit that like button and subscribe for more. Cheers!